Motion, and we are Team 17. And introduce again is Ting-Hsuan, Wang, and me, Hsiao-Yu. Let's begin with a short story. Long, long ago, people used ropes and stones to do a calculation. And as technology developed, more powerful tools were used, and something out of the date were wasted. And since got thinner, smaller, and faster, and more things were wasted, although they still can be used or still new. Now is the era of touch. But is it still necessary that we throw away things that are still new to follow up the trend? No, we don't have to. You might say, what? Because we have space motion. Just put it in front of your monitor, just like this. Then your monitor can magically become a 3D touch panel. Let me introduce you our project, Space Motion. Life is just a touch away. This is our mark. The blue rectangle represents our product is like a frame. And the yellow part means your finger just touch inside. And the two red circles means that our product has unlimited potential. Space Motion is a rectangular frame that contains sensors and high-speed recognition and calculation solutions. This is our product. We photo it in our campus. With this frame, normal monitor can become 3D touch panel and controlled by simple gestures. Then you may question, if we use 2D monitor, then what's the difference between our product and normal iPad or 2D touch panel? What's better? Because we provide you 3D touch experience, our sensor can not only detect the position of your 2D position of your finger, but also the depth you get inside the frame. Then nothing is impossible. Everything you imagine in the real world can be done by the computer. Then you might question, if it is 3D, then compare with Kinect or other motion sensing game box, what's better? Because I will say that we have space-saving properties and user-defined position. Look at the left side of the picture. This is a Kinect user. If you are too closer to your monitor, then it can sense your whole body and you can use it. But our product, the sense is inside the frame. So if you hope you can get close, your finger can get closer to the monitor, you just put it just in front of your monitor, or you can just put it back and closer to yourself. And it is easy to fix position. Just align the mark on the product with the middle of your monitor. That will be okay. So just put this frame and align the middle of it with the middle of your monitor. Then you can start using your space motion. Then we will come to the question, why? Why do we need space motion? I'll say it's really helpful. Help, H-E-L-P, is our full purpose for designing this product. H means high potential, E, environmental friendly, L, low cost, and P, promote. I'll say it's really high potential because you dig into the algorithm and have detailed gesture recognition. It can further develop into support device on 3D graphics and games or even virtual reality. And it's also environmental friendly. As we mentioned in the previous short story, we know that with its add-on properties, we don't have to throw away our monitor. And it is also low cost. You don't have to buy another monitor, and also our algorithm is simpler than the product on the market like Kinex. So even people in poor country can enjoy the convenience. And also it promotes your using touch panel experience from 2D to 3D, more intuitive manipulation. Then we'll say, how do we implement it? Where's the magic? The secret is on the left side and the down of the space motion, we have 2 cameras as sensors, and we'll calculate the number of a finger and its position. Look at the picture. It is a monitor, a space motion, and a magic book. On space motion, we have 2 cameras, and the magic book, we have 2D270. Then the camera 1 will calculate the position of X of your finger and send it to D270. And camera 2 will sense the position of the Y of your finger and send to D270, and then will communicate. And then after a series of calculation and identification, they will send out the picture to the monitor, and the picture will change. This is our structure. It can separate into 3 parts. The first is finger detection. It will decide how many fingers and where's the finger, do you have finger in the frame. And the second part is gesture identification. It will decide that what gesture you are acting. And the third part is the memory part. Let's talk about the finger detection. If you put a finger inside the frame, then the camera will sense it and take a picture. Then we will process this picture by a line. On the line, we will get pixels and use skin color formula to decide if the pixel is recognized as skin color. So the circle one is skin and the gray one is not. And if we have 20 to 100 continuous skin pixels, we will recognize it as a finger. But in real condition, because the light or individual skin color, it will have a continuous part. Well, we figure out the solution that we add a system that regards less than 15 continuous non-skin pixel is okay. So if you look, there are 2 gray pixels inside the continuous series of skin pixels. Then we will consider it okay and think this part is all of 1 finger's length. And for finger position, we will get start point and end point and average it and think it's a finger position. Then how do we know we have 1 finger or 2 finger? Look at the picture. If we have a line and you got 0, the number 0, then the finger you detect, you will regard it as finger 1. And then the number will change to 1. And if you got 1 and you got a finger position, you will regard it as finger 2. Then change the number into 0. So use this number, we can know which position is finger 1 and which position is finger 2. And for the depth part, if you got a picture, then x-axis represents the position of your finger on 2D plane. And so the y part means that the depth you get into the frame. And so look at the picture. The 950 line has no finger, and the other part has. So this picture means that finger depth is between 850 and 950. Then let's talk about the gesture identification, like selection, like he just present just touch it and then get into a room. The selection will recognize if finger number is 1. And on later on algorithm, we know the position of X and Y. And if they are in specific range, we will consider that it touched the item. And turn page. If you look into the gesture you present, then you will find that your x-axis gets bigger and y remains steady. Then we will recognize it as turn left. And if x gets smaller and y remains steady, then it is turn right. This is the picture we've done before. It is an alpaca in 3D graphic. And forward part, we will define normal line, threshold 1 and threshold 2. If you pass the first threshold, meaning that your finger is deep enough into the frame, so you will get the first forward steps. And if you get into the frame, then it will pass the second threshold and you will get the second forward steps. And scaling. Look at the change of your finger. You will find Y1 and X1 get smaller. If this is the 0 points, then Y1 is the lower point, it will get smaller, and S1 gets smaller. And the other two get bigger. And smaller is the same. And let's talk about memory part. We use flash into SSRAM and into VGA. And flash has 8 megabytes. And so we have 12 pictures in one flash. And because we have too many pictures, so we got 2 flash. We have 2 flash to support the function. And the picture is like this. We have the first 12 picture in the main D2, and the other is named support D2. Get the other 12 pictures. And if the first to the 12 is okay, but if it is above 12, like 17, then it will send to support D2 and tell it to get its first picture out and to its SSRAM and send to the VGA output. And look at our product. We have backgrounds and a picture. The background is sent by the system, and the picture in the middle is sent by the SSRAM. And this is the chart that where our pictures come from. So if it can use in the library, it will be like this. The D270 can hide in a magic book, so it looks just fit the background. And space motion is very potential in gesture recognition development, so everyone can buy it and get more developed. So what can it do? Just we demonstrate. Selection, turn page, forward, get in, and scaling. And in the future, you can combine with 3D graph, use virtual reality, 3D graphics, interaction TV, or more detailed gesture development you can use on air mouse or games. And with projector, what will happen? On the wall, we project the picture on the wall, then it can become a huge panel. Space motion can lighten up your every possibility. So thanks for listening.